Look, I'm just a geologist. I like rocks. I love rocks.
Good.
All right. Good evening, everybody, and welcome to the Geology Flannelcast. My name is Steve.
Hey, I'm Chris.
I'm Jesse.
And tonight we have our special guest, Alex.
Hi. Thanks for having me.
Thanks for coming on, buddy. Now, why I said special is because Alex is like a junior geologist.
Don't say that.
Or, what do you call your science again?
Archaeology. If you could call it a science.
You may have heard of this field. You may have heard of it.
Yes. There was
That's like Indiana Jones, right?
Exactly.
Yeah.
I was going to say there was a
Running around
4-part
with the woods.
documentary I remember watching as a kid.
Do you ever, like, when you're doing field work, just go to other people and say, it belongs in a museum?
I actually have a confession. I've never seen the Indiana Jones
Oh
movies.
my gosh.
Wow.
Yeah.
That
all right.
concludes the flannelcast for today, ladies and gentlemen.
That's a bold statement. Not only just for any, human on the planet, but for an archaeologist to boot. That's crazy town.
Well, I'm just going to share my screen now, and we're going to watch it for the next 6 hours.
I hope you have popcorn. Yeah, we'll skip the last one. The last one was okay.
I've watched it several times. That's my dark confession.
The crystal
seen-
skull?
Yeah,
Yeah.
I've seen it several
It's
times.
garbage.
It grows on
No,
you.
it's
It
not
grows on
garbage.
you.
What part of him surviving a nuclear blast in a refrigerator grows on you?
It was lead lined. Come on. I'm sorry, we're spoiling it for Alex.
Yeah. I don't want to
It's
hear how it
horrible.
ends.
Yeah.
Yeah. I
Didn't
actually,
anyone pull in aliens or something?
well,
Yeah.
Yeah, there's
Mm.
yeah. I mean, you could do without like the last 20 minutes where the alien ship does its thing.
But
the
think about the
action-
last 20 minutes of the first one, Raiders.
Love it. Love every minute of it.
I understand,
do.
but it's a higher being comes down and melts everybody's face off.
That's a good point when you put it like that.
Yeah.
I got in a dark place one time when I was watching Crystal Skull for like the second or third time. And I had a few beers. And after the atomic bomb scene, Alex, takes place in the first 5 minutes for reference.
Okay.
I paused it and I was like, were refrigerators lead lined? And I went on like a 45-minute rabbit hole, like, were old school refrigerators, why would they have lead in them? Turns out they wouldn't.
No, it is a terrible, it's not an insulator. It's a terrible insulator. It's a conductor. Yeah.
So the movie with aliens and nuclear bombs wasn't historically accurate?
No, it turns out no. It turns out.
also, what's the guy's name? Shia LaBeouf? Is that how you say his first
Yeah.
name? Shia LaBeouf? He's in it. He's like the worst actor in the world.
What,
There you go.
His
I
name
said
is
it.
Mutt.
In the movie, his name's
Yeah.
Mutt?
Mutt, yeah.
Anyway,
fan.
so Alex, thank you for coming on.
Yes, thanks for having me.
Alex is an archaeologist and doing research at the University of Connecticut. Go Huskies.
Go Huskies.
Yeah, you did your undergrad there as well?
Yeah, I've been there way too long.
I know a thing or two about being at college
Yeah.
too long. So,
Steve had 4 junior years.
Wow, all right.
but it was only after my second sophomore year. So, all right, are we going to do a little Jesse's Corner before we dive into?
Yes.
I mean,
As I get a blank
yeah.
stare from Jesse.
No.
That was fear. I smelt it over here.
Jesse's Corner. This is new.
Yeah.
We give you one job, Thornburg, all right?
Throughout the week, I find all of these really interesting. We talked about this last week, how I have like 50 tabs open.
Yes.
That didn't make the cuts, by
on
the way.
multiple browsers. Yes.
Oh, it didn't make the cut?
That didn't make the cuts.
You edited
no.
that out? Well,
I had
I'm
to
getting
take it
back
out.
in. I have many tabs open. Try and edit this out.
Yeah.
This will be edited out too. So continue. I guess.
Well, since last week, I have many more tabs open.
Let's
now.
talk about Murder, She Wrote. That also got cut last week.
Perry Mason. It was Perry Mason.
Sorry.
Yeah.
It's all the same.
We'll have a Geology Flannelcast director's cut one of these days come out. All the stuff that doesn't make
Yeah.
it to the
That's
the
the
final.
Patreon diamond level.
It's nobody wants that level, right? That's
All right. So this week, I've got 2 pretty interesting stories that run the gamut here. The first big picture plate tectonics, if you're familiar. So I think we talked about this sort of recently. We talked about mountain heights. Did we talk about this?
Yeah, Plum Bobs and Everest.
Yeah.
I saw this article today about this.
The mountain height might be controlled by tectonics rather than erosion.
Yeah.
Yeah, it's really interesting.
It's about how fast the plates are moving. And
yeah, so there's, when you think about mountain height, there's basically the three forces involved in terms of how high a mountain can rise are going to be plate tectonics, isostasy or isostatic balance, and erosion, so weathering, so climate. And so for a long time, it was always thought that erosion is always going to happen faster than the mountains can uplift, and plate tectonic processes are occurring. And now there's a recent study out in Nature from this week, from literally this week. I assume everyone listens the day this podcast drops. So this is the second week in June.
This will drop June 16th.
Yeah, so this is from June 11th. And it's just basically by sort of looking at, they're taking into account sort of, they're actually looking at the isostatic response, which sort of keeps pace from the way they're modeling it, regardless if it's erosion or tectonic uplift. And they're saying tectonic force looks to be the dominant control here. They're looking, it's in convergence zones, obviously. Yeah, Steve, I don't know.
So this doesn't not too many mountain buildings in divergent zones.
Well, normal faulting.
Yeah, you get
That's not mountain building.
Well,
That's mountain shrinking.
Basin and range out in Nevada.
Divergence, you have some buoyancy from the hot crust, but that's more of like you're just sitting higher. So like the mid-ocean ridge sits higher. The reason it's a ridge is because you have hot basaltic magma coming out.
It's hot and it expands. It's bigger.
Yeah,
but you're not going to build bigger mountains by pulling stuff apart than you are by smashing them together.
Well, no, and you're not going to I guess this study is for like the biggest. I don't know anything about this. This is the first time hearing about this, but this is for like the biggest mountains that we're dealing with, like the Himalayan type.
Well, no,
ranges.
it's actually one of the places they looked is in a subduction zone. Is the Andes.
The Andes, okay.
And they're saying the Andes, aren't that big of a mountain range.
They're 20,000+ feet.
Yeah, it's okay.
What do you mean that's okay?
I think it's the tallest mountains outside of the Himalaya.
Yeah.
They're huge, yeah.
Okay. Well, their whole thing is you have high relief there, or excuse me, high erosion, but they're still very big.
Mm-hmm.
So, they're saying, it's the rate at which the tectonics is happening. And I guess in subduction zones, the rate is faster than at, say, continental collisions. I'm not going to lie to you. I didn't get into the nitty gritty of this paper because
no.
I can't give you exact answers here. It's going to leave you unfulfilled.
But it is interesting that someone
retook
a look at something that we thought everybody knew what was going on. And that's what I love about science.
Yeah. This, just looking over it, I read it when it first came out 4 whole days ago. It's a lifetime. And
in COVID life it is. Days just blending into each other.
Yeah. So I'm just rereading it. Like I'm just skimming through now and I'm like, oh man, this is really interesting, because they get into how, so one of the problems is about if you erode all this material off, you have this isostatic rebound problem that you don't necessarily see as often as you maybe should if erosion was the dominant process, say in the Andes, you're shedding all of the sediment, you should see, this isostatic rebound, this rejuvenation thing going on, and it's you don't necessarily see it as much. I guess.
I'm still a little confused, and I don't know if you can answer this or not, but probably I don't know. No, but seriously, like how
just shaking my head no if you're watching the video of this.
How I just don't understand. Maybe it's just something that I don't know. I'd have to read it and go more into the nitty gritty. But how can you have a mountain building event with erosion being the most dominant force? Wouldn't you think that that would cause everything to go down?
Yeah. So the height is limited,
right?
So it's only going to go like if you have high weathering, if your climate is such that you have high weathering, there's a maximum height that the mountain can reach.
Yeah. Look, think of Olympus Mons. Like Olympus Mons is what, like 65,000 feet on Mars?
69, dude.
Sorry, dude. But there's no erosion to, basically buzzsaw it down as it's growing.
Olympus Mons is a weird example because it doesn't have the same gravitational constant as Earth, so they can get.
No, I understand, but I'm like that's the way it was always explained to me. Like, oh well, there's no real weathering, and and gravity's different, but weathering seemed to be there's no weather, so nothing's getting eroded, which made sense. But so did catastrophism.
Would there still be like sandstorms and stuff? Would that cause some amount of weathering?
Sure. I mean, abrasion.
Yeah, absolutely.
I think the dominant thing that causes mountains to break apart is freeze thaw.
But and pressure unloading.
Okay.
Yeah, but they work together, right? Because pressure unloading creates the cracks and the freeze thaw.
Yeah. And the gravity brings it all down.
Gravity's the worst. Or the best. I don't know.
You heard it first here, ladies and gentlemen. Gravity is the worst. That should be the T-shirt that we make.
Yeah.
Catchphrase right there.
And then, speaking of gravity, I keep seeing popping up like they proved a cornerstone of Einstein's theory recently, but that's all I read the headline.
That's the best way to do it.
Yeah, but
because we all know headlines are.
Hey, accurate. It almost. If I was a physicist, I probably would have clicked on it, but I am not. I am not. All right. So, what's your other article?
You're pushing me along like I was done. All right. So
I just assume Seminac's going to edit this out anyway. So
Thornburg, shit or get off the pot, man. Come on.
Yeah. So
way to drop a curse, buddy.
Yeah. Get that edit button, or at least we need to get like a beep button.
Ooh.
It all comes in post processing.
The next one was
I'm going on Amazon right now to see if I can find a beep button.
You're gonna get a physical beep button.
Yeah, exactly.
Not a computer.
No, it's gonna be like a buzzer in like a quiz game.
Yeah. He's got categories or something.
So this one it was a study out of Penn State, and it looks at, and they're really quantifying. There's a real and sort of this. Some of this is sort of intuitive for us that do soils, but the bedrock type under forests has a direct influence on the species of forest, or species of tree that's growing. Which that sort of makes sense, right?
Nutrient based.
Yeah, the bedrock.
I think like spodosols, you get pine trees.
Yeah, it's going to affect that. But they're also seeing that the type of bedrock affects how much growth you have and how much carbon gets stored, which is
type of bedrock affects how much carbon gets stored.
Which is it has implications for how we quantify the carbon cycle when we think about like CO2 cycling in and out of the atmosphere.
So are they talking about like potentials for like carbon sequestration?
I think it can go that way. Yeah, it's dealing with forest management now in terms of what trees you find in certain forests and whether or not like how you you're cutting down trees and what trees, because if your forest is not good to promote growth, you're going to want to not cut down as many trees, I guess, especially if that carbon, you cut down a tree and that carbon doesn't get locked up in the soil. Well, then it's just all going in the atmosphere.
Mm-hmm.
Shale bedrock stores about 25% more live above ground carbon. And trees grow faster on shales, so they take up about 55% more carbon each year than sandstone bedrock, which sort of makes sense in our neck of the woods in the valley and ridge of the Appalachian. We have these deciduous trees that like sort of shaly soils. They're not, a sandy soil is going to be more for
conifers.
Yeah, your conifers, if we can get a little bit into the trees. So it's an interesting little, in the valley and ridge of Pennsylvania, which is what I know. It's all
which is essentially the center of the universe.
It is.
Mm-hmm.
If we could pinpoint it.
Yeah.
You have the valley ridge is sort of interesting because you have, as the name implies, valleys and ridges. But you have this mix of shales and sandstones throughout those valleys and those ridges. There's some limestones in there as well, but we don't worry about limestones.
It's the valley.
In this house, we don't worry about limestones. But it's a good natural laboratory to sort of look at this influence, and I'm glad they looked into it.
That's really, really cool.
How about that?
I'm part of this. I've been talking to some folks at Temple who are doing a thing with carbon sequestration, and I had never done anything with it before and knew much about carbon sequestration in soils, and so I've started looking into it in the past week, and it's really turns out there's a lot there. But how we use, and the thing I've been reading into is about agriculture and how different crops, how they lock up carbon either in the soil, in their roots or whatnot. And it's all very interesting. And I think it's something we don't think about a lot when we think about how carbon moves around our environment. And when we think about, CO2 in the atmosphere or whatever, we fixate on fossil fuels, but land use is 1/3 of all, carbon dioxide. Every year, 1/3 of all carbon dioxide into the atmosphere is from land use change. The fun fact.
Interesting.
So it's something with a lot of potential and something to sort of think about.
That is really, really interesting. But it's also a good segue.
Yeah. Carbon.
Climate change.
Huh.
What? No. So Alex, like we said, is a junior geologist / archaeologist. You study Cro-Magnon man? Is that
Neanderthals mostly?
Neanderthals.
Yeah.
Sorry.
Yeah.
I'm sorry. That was deliberate. No, Neanderthals and but all over the world, like the not where Seminac is in Georgia, but the country.
Yeah, the country Georgia. Yeah.
Armenia and Lithuania? No.
Israel. So I've done some work in Israel as
Israel.
well. Yeah, and some in Germany. When I was in undergrad, I got to spend some time working on an excavation in Germany as well.
When you were an undergrad, you got to spend time doing an excavation in Germany.
Yeah, actually, so when I was an undergrad is when I started working in Armenia.
Should have went to UConn.
Yeah, That's actually what got me into archaeology in the first place. Is one of the professors at UConn, Dan Adler, runs a field school in Armenia, and so this was 2011. I went there. It was between my junior and senior year of undergrad, and got to excavate, got to do all that at a site in Armenia.
That sounds awesome.
Yeah,
it was a lot of fun.
I did some field work in Western Massachusetts. Not as exciting.
Basically Armenia. Yeah.
We often refer to Western Massachusetts as Little Armenia.
Yeah.
This is sort of a side note.
We never do this.
I get the impression that everything saying is really on task here. So.
Chris was literally yelling at us before you got on. Staying on task.
Stay on task.
Is Armenia, and this may be a sort of touchy subject, I don't know the people you work with, is Armenia home to that one archaeologist who uses like a bulldozer, and he just goes he's quantity over quality, so he'll go through and just like bulldoze an area and like sift through all the remains and whatever he finds in like the bulldozed area.
So I've never heard of that in Armenia.
Okay.
Or not necessarily, but that is something that happens fairly often, or used to happen a lot more in the past.
Yeah.
So like the excavations that I was doing in Germany, for example, one of the sites that they were excavating, they were actually digging through the back dirt of excavations that had happened in the 1930s. The site was called Vogelherd, and it's got these really beautiful like ivory figurines of mammoths and birds and horses, beautifully crafted stuff. But the guy who excavated it in the 30s basically just shoveled everything out and like dumped it over a hill. So
wow.
Then back in I think it was, I was there in 2012, but it had been going on for a few years. They then kind of put together the resources to dig through that back dirt to find all the stuff that he missed, basically.
Holy cow.
And there was a lot of it. There was a lot of stuff that was missed.
Now, did it go in a museum?
It did, actually. There's a beautiful museum in Stuttgart that has all of these finds in it.
Nice.
Wow.
No, that's really, really, yeah. Yeah. Maybe,
yeah, I mean,
maybe I should have been an archaeologist.
Yeah. Yeah.
So, Alex, okay. So, what kind of stuff, for the listeners out there, what kind of stuff are you interested in researching?
Yeah, so I study climate change in the past, looking at leaf waxes. So these kind of molecules that are part of the waxy coating on leaves, they get deposited in sediments and soils, and you can extract them and then measure things about how the environment changed in the past. So this has been a common technique in geology for the last 20 or 30 years or so. But archaeologists just basically take methods from other fields. That's kind of what we do. So now we're just taking this method and applying it to archaeological sites.
Don't feel bad. Geologists do this all the time.
Okay, I don't feel bad about it. I'm just saying that I did it. Yeah, so in a way, it's beneficial because when people are looking at like archaeological collections and stuff, everything's going to be time averaged, and there's all sorts of stuff that gets mixed together. So then oftentimes when people are talking about climate change and how it affected human evolution, then they would compare an archaeological site that's somewhere to like a lake core that's maybe 100 kilometers away. So it gives us the benefit of being able to get kind of the direct environmental proxies from at the site or around the site, and compare it with the behaviors that are going on there, rather than conflating things that might be at like slightly different times or in different places.
Very cool. So what is your, this is a random thought that just popped in my head. What is your timeline? Like from like, let's say today's zero, how far back are you looking?
Yeah, so the oldest stuff that I've worked with in Armenia is probably 400,000 years old. Up until one of the sites that I'm working at is after the last glacial maximum. So to like 14,000 years ago. It's not continuous. There are definitely gaps in that record, but the archaeological record in Armenia, in the Caucasus in general, spans quite a long time. So the oldest archaeological sites outside of Africa are in Georgia. It's a site called Dmanisi, which has these beautiful Homo erectus skulls, and it's an amazing site, and it's about 1.8 million years old. And so as far as we know now, that's the oldest archaeology outside of Africa.
Oh, very cool.
And it's like right across the border between Armenia and Georgia.
Yeah, but the 400,000 years that you were talking about, like, that's no joke. Like there's a lot of climate change that's happened in the last, a little less than 500,000 years.
Yeah.
So
a lot of climate and a lot of human behavioral changes, right? At that point,
we've had our ups and downs.
Yeah. And species have come and gone, and somehow we ended up with just Homo sapiens on the planet. And so that's kind of the question that I'm interested in looking at is, why aren't Neanderthals here anymore? Did climate change play a role in that, or was it other behavioral things? And then also looking at the climate context of why humans then kind of spread out across the globe.
So what's the answer?
Yeah. So my question is going to be,
don't leave us hanging.
What are the? And I'm sorry, I really don't know too much about the Neanderthals, but what's like some of the leading hypotheses that on why they met their demise?
Yeah. So so a lot of people do tie it to climate change. That there were specific events that would have caused maybe population demises in Neanderthals prior to their initial contact with Homo sapiens. It could have been just demography, that they lived in smaller groups. They might have been less mobile, or had not necessarily inferior hunting technology, but different hunting technology. I mean, it was good enough for them to live in glacial Europe for 150,000 years. But then,
I actually I'm teaching climate and climate change in my class, and I have to say I have to issue a correction tomorrow during lecture from reading your paper. I didn't realize Neanderthals went extinct 40,000 years ago. I thought they went extinct at the end of the last glacial max. And I'm a fool.
Make it.
And
You're off by 20,000 years, Thornburg.
Well, I'm way off.
So there might have been some like later surviving Neanderthal populations in like the Iberian Peninsula.
Okay, so
there's some debate about that, but not post LGM.
Then I'm just going to say I was right. I also ascribed it to, I said it was climate change, and I said they're like me, they're built for cold weather. But 40,000 years ago, that's an interesting time for them just to kick it, as it was, in the bad sense, not the good sense.
Yeah, we've all kicked it.
Yeah. That's interesting. That's interesting.
So
really interesting.
You hear like when people take these, and this might be a really stupid question to ask, but it's actually the first thing that popped in my head when we started talking about Neanderthals and Homo sapiens kind of overlapping. Like how much you hear like when people take these like 23andMe tests, right? Like what percentage Neanderthal are you? Like, how was that like a real prevalent thing that Neanderthals were like interbreeding with Homo sapiens, or do you know anything about that?
So I know some about it, and we know that it happened, and that it happened enough that obviously the Neanderthal genes persist in us today, and it's very likely that it happened over a course of a number of years, right? So this isn't my work, but if I'm remembering these papers right, so there's a site, I think in Romania, called Oazi, and it had a Homo sapien that when they did the genetics work on it, they found that it had a Neanderthal ancestor within the last like 4 generations or something. And that was around 10,000 years after you see the initial introgression of Neanderthal genes into Homo sapiens. So there's at least like kind of a 10,000 year window of this overlap where contact was happening between the species. And there was some amount of interbreeding going on.
Just crazy parties, man.
Everyone gathered around the campfire.
Yeah. So like I'm sorry, I know this like this isn't like directly your field of research, but like how weird was like, or I guess it was really weird, I guess, but like, so how
might not have been weird. Don't shame them.
Yeah, seriously, man.
Whatever floats your boat. I don't know, but like
that's what I'm saying.
No, but like in all honesty, like how different were Neanderthals from Homo sapiens?
And is it Neanderthal or Neanderthal?
Neanderthal is proper.
Thanks,
It's
Seminac.
It's because it was found in the initial skeleton was found in Germany, in the Neander Valley, and Tal is the German word for valley. But at the time they spelled it with a th instead of just a t. Yeah, okay, so Neanderthal is
cool.
Technically correct, but I never would have corrected anyone who said Neanderthal.
Does it
I
make
would.
when you have someone like me as a geologist just teaching like, yeah, they went extinct because it got warm. Does that make you a little crazy or?
No, it doesn't. Because I mean, I try and teach
honest,
geology stuff sometimes, and I'm sure I get that really wrong. So
yeah, I don't mind. I'm going to correct myself tomorrow.
Yeah.
But I don't mind correcting myself. But
yeah, no, because the truth is, I mean, it could have been a number of different factors.
Yeah.
It seems like based on like a lot of archaeological evidence that like Neanderthals didn't have like projectile technology. So that's something that a lot of people say, like maybe like if modern humans were using things, you know, if you could stand here and kill a bison that's 30 meters away instead of having to go up and stab it with a spear, that'll provide some benefits.
Yeah, a woolly mammoth will notice you like just stabbing it with a shank.
Yeah, and there was a study that somebody did, I think in the 90s, that looked at the bone breakage pattern on Neanderthal skeletons, and basically it was the same pattern that you find in rodeo riders. They were like up close hunting these things, and there's danger associated with that.
They just went up in my book.
That must have been badass.
Who went up in your book? Rodeo riders or Neanderthals?
Neanderthals. I don't know if it actually might say something bad about rodeo riders.
Yeah.
But I do like I think back to the early 2000s when I was an undergrad and like having some older professors talk about Neanderthals, and there was a thought that they were just outcompeted and they would war with humans, when they were modern humans. And so there was this, we were just, faster, stronger, smarter. But I don't think that's really the case anymore. I think we've moved away from that to a certain extent, right?
Yeah, and I think there are some archaeologists who would say, like if you put a Neanderthal in a suit and a hat and they were just walking around the street, then you wouldn't notice a difference. I don't think I'm quite there yet.
Yeah.
But they were sophisticated hunters. They were able to survive in varying climates for tens of thousands of years. They were definitely competent. For sure.
So, like based on looks alone, though, like, is there like a real definitive difference? Like, so one person says if you put a hat on them, then whatever, you'd think it's a human or like a really goofy looking human at least. But their physiology was different from human.
Yes,
from
yeah,
Homo
definitely,
sapiens,
and yeah, and you can tell them apart based on skeletons. Weird things like we have chins. Neanderthals didn't have chins. Homo sapiens are the only hominin that has a chin.
Wait. So, what do you mean by that?
What?
Like a protruding chin, a chin that sticks out.
Oh, it sticks. Okay, so
yeah, so
like monkeys, like chimpanzees, don't. It just kind of their chin, jaw kind of comes down.
It curves down.
I'm looking at some pictures now. Yeah, that's about that.
Wow.
And I don't know if you remember
that's cool.
Do you remember the documentary Teenage Mutant Ninja Turtles?
Mm-hmm.
The documentary,
they would walk around the city with just a hat and a trench coat on, and nobody would notice.
Yeah, I feel like that's more on that city because they're turtles.
I think the only thing that was true about the Ninja Turtles was the 6-foot rat that lived in New York City, because there's some pretty big rats in that city.
Yeah.
No, that's fascinating though. I never like, of course it's like, I just never thought about that.
Well, I think this sort of leads into, especially what you're doing with the fire aspect.
Mm-hmm.
They were smarter than we're maybe giving them credit for.
Yeah. So that's really where, the research that I've been doing for the last few years is really looking at how Neanderthals were using fire. And because it's something that I guess has changed in the back and forth in the last 10 or 15 years in archaeology about whether or not Neanderthals could just create fire or if they could just exploit fire when it was available on the landscape. And it's also very difficult to tell the difference between those two things in the archaeological record, right? If you're excavating sediment at a site and there's a fireplace, you don't necessarily know how they started that fire, just that it's there, and in association with all these remains.
But like how prevalent, like, okay, so in a natural setting, how prevalent would fire be? Because from lightning strikes, I would assume that that's the only way to get,
Yeah, fairly prevalent.
You really?
Yeah, enough that maybe you couldn't have access to it all the time, but if you had some ability to maintain it after you get it the first time,
I think
you could maintain that for a long time in like tinder boxes. And like there are ways to have kind of low resource use ways to manage fire.
Yeah, we live in such a society where we don't have the forests that we once did, and B, any lightning strikes that do start brush fires are instantly put out.
That's true. Yeah.
You don't. It's not on our mind.
Well, yeah, you're right. Because the first thing I was thinking of, like when I first asked that question, it was like, because I go hiking all the time, and like you never see like fires burning, or just randomly burning. But yeah, we have.
You're hiking in the wrong spots.
I'm hiking in the wrong spots, and but like we have a whole branch of a whole division with municipalities that their job is to make sure that there are not random fires. We don't want that. We're at the point now where we can control fire, but. Yeah, that's
so
kind of wild.
Are you trying to develop a theory as to, hey, this fire was started versus this fire was like found in the woods and brought home?
Yeah. So what I did was there was a team of researchers in southern France who were trying to look at this question in kind of a better way than archaeologists had looked at it in the past, where they just kind of assumed that fire with stone tools meant it was created. So they looked at the record of fire use by Neanderthals there in relation to wildfire changes. And what they found was that there, the Neanderthals were using fire in the cave when wildfires were most available on the landscape during periods of warmer temperatures, basically. So that's kind of the opposite of what you would expect. You would expect more fires when it was colder because you would need it for heat and warmth and cooking things. So they concluded that there, the Neanderthals were just harvesting the wildfire whenever it was available. And they also looked at things like, stone tool density and that kind of stuff, and they found that it didn't correlate with one another. So it wasn't just that there were more Neanderthals there when it was warmer, but rather they were just using fire more there. So go ahead.
No, I was just going to ask a random question about. I know there's sort of different thoughts on when they actually started, if or when they started actually cooking food. Do you see evidence?
Yes, but I think everyone would agree that Neanderthals were cooking food. We find like burnt bones and that kind of stuff all the time.
Okay.
That's like earlier in time with like Homo erectus.
That's like archaeology 101. Come on, Jesse.
So I will say, a lot of my knowledge of this, I'll make my disclaimer, is that, so a lot of the people I went to grad school at Rutgers did work in Eastern Africa. So
Rutgers has a great department there. Yeah.
Is a lot of my knowledge is 1 million, 2 million years ago. And,
yes.
Yeah. So yeah, sorry to be asking such simplistic questions. So this is really interesting.
So with that, with kind of this like framework that this other group of archaeologists set up, then we tried to answer these questions in Armenia to look at if we could kind of reconstruct fire use at the cave, if we could reconstruct wildfire in the landscape, and then tie that to climate and human behavior and see how that all kind of pieced together. And so that's where I turned to the geologists that I work with. So Mike Wren's lab, who is Chris, who is the guest last week's, his advisor. I've been working with him for a number of years doing this like compound specific stable isotope analysis to reconstruct climate in the past from the plant waxes. And they had started working with PAHs, the polycyclic aromatic hydrocarbons, which are these molecules that are the byproducts of fire.
Okay.
So
it comes from the incomplete combustion of carbon.
yes. So
That's all I know.
So we thought that we would try to extract these from the archaeological site to see if they would kind of retain a record of fire use at the site at the time. And you can kind of like generally break these up into broader categories where there are some that have more of these carbon rings in them, the PHs. And when we were looking through the literature, we found that those were produced more in kind of smaller campfire-like things. And they stay pretty close to the source of the fire because they kind of bind to the particulate matter that's being emitted from the fire. So like the charcoal and the ash, so they stay pretty nearby. So we use those to reconstruct fire use at the site. And then the lower molecular weight PAHs, which travel pretty far and are produced a lot during wildfires. Then we measured those to look to reconstruct wildfire during the same period of occupation. And basically what we found is that those two signals looked completely different. So the heavy PAHs were doing one thing, the lighter PAHs were doing another thing. So it doesn't look like they were using wildfire just when it was available in the landscape.
How cool is that?
That's really
Yeah.
good. So you could tell.
You showed those Frenchmen what was what.
Well, I mean, they provided the framework for me to answer this question. So
you could find like where the fire started. So like if I was looking at soil or something and I found these heavier PAHs, I could say, all right, the fire started here.
If you found the concentration of them, maybe. I would say the difficulty with that right now is that PAHs are everywhere because it's part of fossil fuel combustion.
You do love burning things.
Yeah.
Yeah.
So a lot of time, I mean, you can like measure distance from a road based on pH concentration because it just gets really and drops off as you go farther from a road. And
so you're working in caves.
Mm-hmm.
Are you away from urban areas or fossil fuel?
Yeah.
Or coal plants? Or?
Yeah, I mean, enough. And also the pHs aren't really soluble, so they shouldn't be like leaching in the sediment in the cave. They shouldn't be moving.
Got it.
Excuse me. Are you so like the stuff that you're finding? Is it buried?
Yeah. Yeah.
Okay. And so then also if it's buried, then it shouldn't like whatever's like getting released now.
Right. Shouldn't be
on the surface of the soil.
Yep.
Yeah. So then
Yep.
you can just look at the strata that you're at and just know like, okay, like it's not like, like what we're doing now isn't like ruining the samples that you'd be looking for, contaminating, exactly. I guess, right? Okay.
Yeah. Yeah.
So when you find when you do one of these digs,
Mm-hmm.
what are you looking for to test for like PAHs, or what are you using? Like what materials are you looking for?
So we're just collecting soil samples. So I collect like a bulk soil sample of
Just
maybe
like kind of hand grab kind of deal.
Yeah, maybe like 100 grams.
Okay.
And then from that, we can usually get enough to quantify the pHs as well as getting the plant waxes for the isotope analysis. So it's
you're not even looking for like, it's not like charcoal briquettes or something like that. You're not finding like any wood remains or anything like that.
So we do find that, but I wasn't extracting anything from those in particular.
Where are you getting the dates from?
So because at Lucicurt it's slightly older than radiocarbon dating range. So in the upper layers of the sequence, it's kind of within it. But the dating techniques that we use is because it's a very volcanically active landscape, they're autotephras. So either directly dating the tephras or geochemical correlations with other dated tephras.
How do you get volcanic tephra in a cave?
It could be windblown.
Okay.
We have some of the geologists that work with us look at cryptotephras. So hopefully I'm explaining this right, but then they take samples and then density separate the tephra out, and then geochemically correlate that. And it's like tephras that are invisible to the naked eye. they can get it from just the wind-blown stuff from that.
That's very cool. So it's like a Aeolian tephra in a cave. That's mind-blowing.
Yeah, and Armenia is great for it because the volcanic activity there is crazy. It's I think about the size of Maryland and has like 20 different obsidian producing volcanoes.
Wow.
Which is wild. But it's also great for us because all of the stone tools that the Neanderthals and I mean modern humans and anyone who lived there, most of the stone tools that they made were on the obsidian.
Nice.
It's really good material for that. And then because each of the volcanic eruptions has a geochemical signature, we can source where they're coming from. So we can figure out how they're moving all across the landscape by looking at where the obsidian's coming from and where they're going to the cave from.
So archaeologists couldn't do anything without geologists.
Exactly. Yes.
So
you are 100% correct.
So do you think, maybe this is putting you on the spot, are all of these volcanoes here with all of this great obsidian for making blades and whatnot, is this the reason you find all of these really old hominid skeletons and whatnot, because they found all of this material and they're like, we're going to live here and we're going to stab some woolly mammoths?
It could be. It's definitely hard to say. I think a lot of where we find archaeological sites is more of a question of access and I think if
you're
you
finding
were to
a
ask
cave
that question,
bones were
and if you were to ask that question, like 30 years ago, archaeology in Armenia wouldn't have been as well known because it was still in the Soviet Union and people wouldn't have been working there as much. So I think a large part of it has to do with that as well. Just the ability to access sites or access collaborators who then can tell you where sites are or do survey work.
Very cool.
So like the cave that you're talking about, that you're working on, how did you find out about that?
So that was originally excavated by an Armenian that we still work with. His name is Benik Uritsian.
Was this one of the bulldozer guys? No, I'm joking.
Not a bulldozer guy. So he worked there. He originally excavated the cave in the 70s. And
so how did he find out about it?
I don't know, actually. That is a good question.
If he's Armenian, he could have just been a kid on his bike or something.
Yeah.
You know what I mean? Like,
yeah.
It has some local tips or something. Like,
I've got a side story that I don't want to. Yeah. So when I did my field camp in Italy, there is this cave in Italy called Frasassi. It's actually like the largest cave in Europe. One of the largest in Europe.
You said that you sound really sure about that one.
it is a cave in Europe.
A cave in Europe. And it's one of the big ones.
What's it called? Frasassi?
Frasassi.
Frasassi. All right, I'll look it up. You talk about it. I'll look it up.
Okay. Grotta di Frasassi, if you want to be Italian. That's bad. Edit that out. I don't want to make our Italians so angry.
It wasn't bad.
We got to do something. All our Irish listeners have bailed out on us.
Yeah. So it's in the Ancona region. But anyway, so the guy, the one guy who was doing the work there, the one professor, lived in Italy, and he was Italian, so that's why he lived there. But he was one of the people that discovered the cave when he was a kid, and he was taking a little nap on the side of the hill. They were out hiking or whatever, and he was smoking a cigarette, and they was just laying on the side of the hill smoking a cigarette after his lunch or whatever, and he noticed the smoke from the cigarette was just getting sucked into like this bush on the side of the hill. He's like, oh, that's really weird. And he like moved the bush away, and there was this big crack in the ground. He's like, oh, what's this? And pushed some dirt away, pushed some stones away, and it led this little like pathway. He crawled into it because he's a maniac.
Don't crawl into no. I get the heebie-jeebies.
Don't advocate crawling into random caves.
No, so they crawled, and they got to a point where it just like dropped off, and so they were like dropping stones, and they couldn't hear it, and so they went back to one of their house. They like dropped some matches. They couldn't see, so they went back and they got 30 meters of rope, and they went back and they crawled back in. They got a few flashlights, and the one guy tied himself around his waist, and the other two friends held it, and he climbed down.
That worked great in the movie Poltergeist, you know.
Yeah, he climbed down, and he had his flashlight. I keep wanting to call it a torch. I don't know why.
That's what they call it in Europe.
That's the British way to say it.
And like he was just dangling there, like it was 30 meters of rope, and he dropped the torch, and you could just see it. And he was like, it was just like a speck of light. Here they were like, he had dropped into like the main chamber, which was like 200 meters tall or something.
Holy cow.
Wow.
So, but he was, one of the first to.
I'm not going to lie. If my friends were at the other end, I'd be dead.
Yeah, seriously. They also, they wouldn't send me down. But that's honestly how these things get discovered a lot of times. It's just like,
crazy Italian kids.
Yeah, they're just roaming everywhere throughout Europe. They're throwing their cigarettes and seeing where the smoke goes.
Yeah.
Maybe edit that out to our Italian listeners again.
But if you're smoking a cigarette, there's nothing. I mean, like whatever. Like,
but I mean,
Jesse's all paranoid now about editing things out. Come on, man.
A lot of these caves are like that. Like, like the cave in South America. Like you just stumble, South Africa. Like people just stumble upon these things.
Mm-hmm.
Mm-hmm.
How do you find out about them? What's the cave in France where all the cave paintings are?
Oh, the cave painting ones.
There are a lot of them.
Cave of Forgotten Dreams, it's called. Yeah.
So
like,
just real fast,
sorry.
People are gonna we just slow
Stay
your
on
roll.
target. Stay on target.
This La Frisassi cave is on the border of France and Italy, and I think it's actually in France.
You're looking at the wrong cave.
I'm looking at the wrong cave. Okay,
Yep.
And that's why I'm not the fact checker. So
Yeah, it's it's in the Ancona, which is down in like central on the Adriatic side. Here's
Oh. All right, well, Jess
Nice.
got it then.
All right. So,
Anyway, sorry. Yeah.
Alex, you have published papers in Nature? Is that?
Scientific reports.
I'm sorry, Scientific Report.
It's not.
But yeah. So please check out, all of Alex's findings. We'll post links on our website, on Facebook, and I don't know where else. I guess that's it. Instagram,
Well,
maybe.
Well, I asked Alex. I got another question for you.
Yeah, I've got a question.
No.
I
I'm
know.
sorry.
Are you wrapping
I
it up?
wasn't
right
wrapping
now?
it up.
Kick
I'm
him
not
off.
wrapping it up. I'm just.
I had a lot of questions yet.
We'll get to
Sorry
the
to
links later,
sidetrack.
right? Like
Sidetracking us.
Plenty of time for the links, all right?
Yeah, I'm sidetracking us with my smoking Italian stories.
All right. So you show up to this cave, right?
Yeah.
And you guys start doing the excavations. Number one, so how deep down do you have to excavate to get to the stuff you're looking for?
So in this cave in particular, it's pretty much right on the surface. The original excavations that Eurytion did in the 70s, he kind of pulled off the first maybe half meter of sediment at the top of the cave. And then that leads us kind of directly onto the Middle Paleolithic, which is the stone tools that Neanderthals are typically making, is the Middle Paleolithic. So it's kind of right there. And then we dug right around 2 meters, and that's when we hit the bedrock. So there's about 2 meters of sediment.
Gotcha. Wow. So do you guys, and one of the questions I wanted to ask you when, sorry, this is kind of backtracking a couple minutes ago when you talked about dating techniques, you guys ever dabble with OSL dating?
Yes. So we have OSL dates from the site as well.
Okay. Yeah. Cause I know you're saying like the stuff that it's too old for carbon dating and you started talking about tephra stuff, but yeah, I do a fair amount of OSL dating. With my research, so I'm very familiar with that. It's pretty awesome.
So we work with Simon Armitage and Lee Bow Simon Armitage, who's at, I can't remember now. I know Lee Bo's at Wollongong in Australia.
Oh yeah, in Australia. Yeah.
Yeah.
I don't know the name, but I know the university.
Okay. Yeah.
Chris, do you want to take a second and say what OSL dating is?
I was just going to say, I only do Tinder dating and Bumble dating.
All right. OSL dating. Here we go. Here's your 30-second spiel. It's really cool. So it basically dates the last time that quartz-based sand saw the light of day. And when sand gets buried, basically there's there's radioactive elements like potassium, for example. It's breaking down and it's spitting off electrons, and those electrons get stuck onto the quartz grain, like in imperfections of the quartz grain. And so the longer that quartz, so when something gets buried underground, it's not exposed to sunlight at all. The only thing to do is bury it a couple inches, and it's in complete darkness. So the longer it's buried, the more electrons it collects, and then basically what you can do is you can look at it and you collect these samples. It has to stay dark, and you can literally take a background geochemistry sample of from where the sand where you're collecting it from. See, basically, oh man, I'm gonna butcher this. It's called the paleodose, but essentially it's like,
that's 30 seconds.
All right. You see how many electrons per year it should collect. So the more electrons you have that are stuck in the quartz grain, the older it is. And that's a really, really, really watered down way of it. Because when the sand is exposed to sunlight, the sunlight bleaches it, knocks off all those electrons. There you go.
And resets the clock. But
it resets the clock. So
just like any true definition, OSL stands for optically. Go ahead.
No, you want to do it?
Well, you didn't define it. You just went into
I got so excited. I don't know. I got nervous. All right. Optically stimulated luminescence.
Yes. So.
Okay.
Yeah. Sorry.
So you basically you date the last time that your sand saw the light of day. There's your answer.
Yeah.
Yeah. So I've helped take a number of OSL samples at some of these sites in Armenia. Taking like a metal tube and banging it into the wall, so that way it doesn't expose it to light as you collect it. And
so it must be easy inside a cave to do that. To keep it dark. Then I've done my background's in coastal geology, and we've done all sorts of stuff. From one time we were actually collecting samples at nighttime, like walking around headlamps, and like that was a mistake. I have colleagues that actually put a blanket. They dig the trench down, put a blanket over everything.
Yeah, there was the time when you went to the Home Depot and you're like, I need all these pipes cut to a certain length.
Yes.
They put you on the list because they thought you were making pipe bomb.
That was the guy gave me a look for that, but when I dropped those samples off at UPS to have it delivered to my lab, they're like, what is this? And I had all these pipes that were duct taped up. And that's always a fun conversation. Like, no, it's science. It's science. Don't worry. It's scientific samples.
That's when we were doing your field work, and I was like, just give me a job where I can be on my own. You're like, here's the GPS.
This is a great story. Yeah. So sorry, we're kind of digressing a little bit, but we're out there. We're working on. Jesse, was that my postdoc or my dissertation work?
That was your postdoc.
All right, we're out in Assateague Island in Maryland, and Jesse came down and helped. Steve was there for that one too, I think.
Vibrocoring?
Yeah, the vibrocoring. Yeah. Steve came down and helped out for that. The whole Flannelcast was out.
Yeah, it was awful.
Yep.
He promised us dinner, and we got back to camp, and it was dark, and he's like, I got half a box of pasta.
Yeah. I was like, I'm going home.
Jesse got Assateague's known for all these like wild horses that run around, and Jesse and I are walking around in the back marsh of this place, and this one wild horse was looking at Jesse and started stomping his hoofs down on the ground.
Not like the cut of my jib.
And Jesse was like, I'm not going anywhere near that horse. I was like, what are you talking? It's a horse. What's going to happen? He was very concerned about this horse. We got into a lightning storm. We listened to Art Bell, the conspiracy theory guy. It was anyways, so I gave Jesse a task. I gave him GPS coordinates, and I said, Jesse, dig down to the water table, collect OSL samples at all of these coordinates out there.
Mhm.
And I'm like, Jesse, do you want anyone to go with you? And he looks at me. He's got his like, the mosquitoes were just heinous out there. He's got gloves, long sleeves on, pants, a mosquito net. And I said, Jesse, do you want anyone to go with you for this? And he looks at me, he goes, no, I'm all right with my own thoughts. I'm all right with being by myself. And he just kind of disappears off into the horizon. I was like, all right. Like, it worked. And
Yeah, Alex, are you ever alone in these caves?
So I'm never alone, like during the actual excavation, no. But because of the type of work that I do with the paleoclimate reconstruction, I do a lot of like modern baseline collection. So like collecting stuff from a few years ago. One, for example, there's a mountain range in the northern part of Armenia that I spent a few days in, just kind of wandering around collecting. The reason that I went to that particular area is because there's an archaeological site at the base of a river, and we're trying to figure out what the kind of river catchment was integrating in terms of the modern environmental signal.
Very cool.
Yeah, so that was a few days where I spent wandering alone.
Yeah. Smoking peyote. Got it. Yeah.
Yeah.
No.
Sorry. No, but that's really cool that you're taking topography, you're taking geomorphology into account, like what was happening uphill, because that's what's affecting our sites. That's what's coming
exactly. And at this site in particular, we're interested in these questions, like we were asking before, like why were Neanderthals coming here? And because it's high elevation, there's a real distinct tree line where it transitions from like the deciduous forest at lower elevations to kind of an alpine meadow at the higher elevations. So I went to collect and see, if we can use these geochemical proxies that I use to differentiate between those two. And then also, is the river sediment itself actually integrating them in a quantitative way so we could reconstruct it in the past, rather than just, saying that it looked like one thing or another.
Mm-hmm. Mm-hmm.
Yeah, actually quantifying it. That's really awesome.
Yeah.
So I guess in terms of your research work, what was, if you could find like one definitive find that like blew your mind away, or like the one thing that you're like, whoa, that's really dope. Like, what has there been like a moment where you're just like, that
Something
like sticks
that I
out?
found myself, or
sure. Just what's like the most, if you had to sell your research to someone, I don't know, I'm being silly right now, but like if you if you had to sell your research to someone and I'm like, this is why this is awesome. Like, what was like the craziest finding that you found doing this work?
I think the craziest thing that I've ever found in terms of like being really interested, especially for somebody who's not an archaeologist, when I was working in Germany, we found a number of ivory beads that were about like 30,000 years old that had been carved out of mammoth ivory.
Really?
Yeah. So it was the like holding something that somebody wore as jewelry 30,000 years ago is like really, you get that feeling when you're like actually holding it and looking at it of like connection to the past. That's
now, who carved it? Homo sapien or Neanderthal? Oh no,
definitely Homo sapien.
Yeah, Neanderthals were dead. Here,
yeah. Now you know.
Changed my whole world here.
but
that's crazy.
That would have been like royalty, like to have that.
Maybe. I don't think so. In hunter-gatherer groups, usually there isn't that much like social stratification. So usually when things are available to one person within the group, they'd be mostly available to all of them.
So they were communists.
Yeah. Yes. Actually. And I don't mean that as an insult.
No, I know. That's actually sounds very peaceful and awesome.
Yeah.
So these people, like in like these like small tribes, they weren't able to be greedy, right?
Yeah.
It was kind of like everyone's watching out for everyone.
Yeah, because so much of it is group survival rather than individual survival. And when you're mobile as a hunter-gatherer, you can't really carry that much stuff with you all the time.
True. Yeah.
So having a lot of stuff just didn't make sense.
So for these types of tribes, how big is that? We call them tribes, number one, like groups
any of those is fine.
How big were they? How many people were hanging out?
that would vary a lot, but 20 to 50 maybe.
Okay.
It's kind of hard to tell, and a lot of these things are based on looking at modern hunter-gatherer groups, which are just so limited in terms of where they live because they've kind of been marginalized by agricultural societies that have pushed them to the brink. So it's
even like, is it even to the point anymore where you can study kind of like these like tribes in the Amazon?
People do, yeah. And so there are groups that still have had limited contact. I mean, their lives have still been affected by the modernization, like global modernization. So you can't say, like these primitive people who live like they did 1,000 years ago. That's not the case.
No, they're still back there smoking Pall Malls and drinking Cokes.
What was the group a couple years ago? There was an indigenous tribe, or not indigenous, like there was a tribe of people that just they weren't in touch with modern society at all, and I think that was a group went over. It was in the Pacific Ocean. I want to say it was like off of India. And basically they tried to go over to convert them, right? And they all got all the people that went over to try to make contact with this tribe got killed.
It's an island. People are always trying to go there, and they're always getting chased away.
Oh man, that must
I can't remember what the name of the island was, but yeah.
We'll look this up real fast.
It's called Delaware County, Pennsylvania.
No, I think
South Sentinel Island, North Sentinel Island.
That's it.
Sentinelese,
That's wild stuff, man. Wow. So so what's on the horizon for you, man? What are you working on? Getting more field work? Trying to get out to once COVID passes over?
I was supposed to go back to Armenia this summer, but that's not happening, which will be a little weird. I've gone there every year since I first did the field school in 2011. So
holy cow! Wow.
Now it's kind of part of my yearly cycle, and I don't know what to do with myself.
Yeah, now you're stuck in the U.S.
Yeah.
So how long are your typical trips when you go over to Armenia?
Usually about a month.
A month, okay.
Yeah. So it's usually because it takes time in the beginning to get things moving, and then we gotta, get the excavation going and find time to then process all the finds that we have and wash stone tools, that kind of stuff.
Yeah, sure, cool. And actually, I had another question about this: the cave that you're excavating in. What type of artifacts are you finding in there? So we talked about you take like the soil samples and things like that. But what else are you finding in this cave? Yeah,
so the cave is full of stone tools that are like all made on obsidian, and they're typical what archaeologists would call Middle Paleolithic. So it's the type of stone tool that is most often associated and found with Neanderthal remains. So we don't actually have any like Neanderthal skeletons at the site, or any like teeth or any like skeletal remains of Neanderthals. But just kind of like typically these two things go together. It's so possible that they weren't. But
what kind of tools are you finding? Like what did Neanderthals use?
Yeah, so a lot of like flake-based technologies, like scrapers that they were probably using for processing hides.
Sure.
We get like point-looking things called Levallois flakes that were probably used as like spearheads on hafted spears, and some blade-like looking things. It's hard to say definitively what they were using each of these individual tools for.
Sure.
But yeah, most likely not projectile weapons or anything like that.
So like as an archaeologist, so you find something, right? You know it's a tool. Like I guess it's just one of those things where like, all right, it's a carved out piece of obsidian. You know it was used for something. How do you figure out what it was used for or what that purpose was?
I'm really happy that I don't do that because it seems like
so you pass it along to someone else.
Yeah,
I got you.
Once you enter Archaeologist Fight Club, you don't talk about Archaeologist.
First rule of Archaeology Fight Club, you don't talk.
Yeah, but there are people. So some people do it based on use wear. So they look at microscopic damage on the edge of the stone tools, and then compare it to, like you have somebody doing comparative research, like processing a hide with a stone tool, and then comparing how those microscopic fractures and stuff on the edge of the tool look.
Like CSI and that stuff.
Yeah, exactly. Some people look at organic residues on stone tools or pots even. I mean, we don't have pots this far back, but you can look at organic residues that are left behind on the stone tools to see if there's anything that then you can tie to a particular behavior. We know that there are things like the site is also full of animal bones that people had hunted. And so you can see cut marks from the bone on the bones from the stone tools, or percussion marks when they take something to like smash open the bone to get to the bone marrow. So we have the bones, so we know that they were doing those kind of things.
Gotcha.
Very cool.
So that's actually really interesting. So a couple of seconds ago, you said that Neanderthals didn't have pots. They didn't use pots.
No.
When did the invention of the pot come around?
Pottery is pretty late. So the earliest pottery is in like East Asia and Japan, and I want to, don't quote me on this, but I want to say it's between like 15 and 20,000 years old.
So we're talking about like clay pottery?
Yeah.
Okay.
Yeah. So it's definitely only a Homo sapiens thing, and even then, pretty late into Homo sapiens.
Yeah, sure. Wow. So the Neanderthals basically, like their limits of tools were basically just cutting things for the most part, bludgeoning and cutting for the most part. Like the simplest stuff.
And they probably use tools to process plant remains, things like that. We have all sorts of some of the charcoal that we find at the site we can identify to species. So we know that they were kind of collecting some bushes and that kind of stuff from the area around the cave and bringing it in for fire.
Yeah. Wow. Cool.
That's so you can tell like what type of wood was burning, or?
Yeah. So I don't do this work, but one of our collaborators, yes, apparently from charcoal, you can, in some cases, identify it to species based on the ring structure.
That's kind of cool.
Crazy.
Yeah.
Wow.
Sounds like voodoo.
A lot of it does.
So another question that I had earlier, and we kind of just we changed topics, but so we talked about like using fire to cook food. When do you know when did that come around? Just
cooking?
Yeah.
It's probably pretty old.
Yeah.
Or at least the use of fire to some degree to process meat. Whether or not it was intentional or the fire itself was intentional, it's probably pretty old. And some people have associated it with the kind of initial expansion of brains in human evolution, right? Because like over time, like Homo erectus's brain gets larger and Neanderthals' brains get larger than the previous. And so some people have argued that cooking meat was a way to get easy access to resources and would also decrease the length of your gut, which is a very costly tissue because you wouldn't have to digest food for longer if it was cooked. So by decreasing the length of your gut, then that would allow for expansion of other costly tissues like your brain.
Oh, how about that?
Yeah. So some people have tied it to that.
People have really looked into this.
Yes.
Wow. So it's basically like you don't have to use all this extra energy to digest food. And so it's almost like there's a surplus of energy. So why not grow your brain a little bit more? Or,
Yeah, or something like that. Yeah, it's called the expensive tissue hypothesis. And I can't remember offhand who originally wrote it, but yeah.
I hope the paper was titled like Brain Food. Early. No? Yeah.
Sure, why not?
Yeah.
Thanks.
All right.
Steve, no reaction.
No. It's burnt steak. It's what's for dinner.
Yeah.
So, Alex, do you guys ever use any ground penetrating radar at these sites to look for potential areas to excavate?
So we haven't, but I do know that we had somebody in our department, Peter Leach, who did a lot of ground penetrating radar work in some other sites. That was kind of most of his dissertation work was applying that to archaeology. So we've never done that. So the cave, I mean, we use the term cave. It's kind of more of a rock shelter. It's not that deep. The bedrock's pretty shallow. So in this case, at least, we have a good idea of where we would want to excavate.
Okay. Yeah. Sure.
Yeah, that was gonna be my question. If how big this cave was. You're saying it's like a rock shelter.
Yeah. So it's maybe I don't know, 5 meters deep and 10 meters wide or something like that.
So I mean, that's not.
It's not small. It would definitely provide a useful shelter.
Yeah. It was. I remember one time hiking with a friend who's an archaeologist. Archaeologist turned geologist, so there's still time for you. Friend of the podcast, Gary Stinchcomb.
Oh yeah, Gary.
I remember one time we were up in the Catskills and like we were just hiking through the mountain. And he was like, "Hey, yeah, that's probably a rock shelter right there." And, like we go like an hour and he'd be like, "Oh yeah, that was definitely a rock shelter." Like all like you just pick out like just they were like overhangs or like little recesses. He's like, definitely if we dug there, we'd probably find something. And I was like, oh, that's really never even thought about it. It's all just rock to me.
Yeah,
maybe that's my problem.
One of them. One of many problems. We'll have a different podcast for that topic, but for another day. Cool. So then, Alex, how much? I guess if I don't know if this is a stupid question, it probably is.
Probably.
So how much longer? Like, if it's not that big of a cave, like how many more years of work do you think you can get out of this thing?
Yeah, he's saying speed it up.
So we're done with.
So it's over. It's
now because of the like issues that I was talking about, like what happened in Germany at that cave where they excavated everything and then had to go through the back dirt. Now it's kind of practice in the field in archaeology to never fully excavate a cave, under the assumption that there will be scientific advances in the future that will lead to better analytical techniques and different questions that you could answer. So nobody fully excavates anything.
So you're leaving like an archive, like when we drill core, we cut it in half, and we have a working half and an archive half.
Yeah, essentially like that.
Same idea.
Yeah, so at the cave, we've dug 1 2x2 meter square down to the bedrock, and then another 2x1 meter extension off of that, and that's it.
I mean, when I eat birthday cake, it's the same way. We're like, I'll have a slice, and I'll be like, all right, yes, that was delicious. I love cake. And then like I come back in the house and be like, well, I'll just have another forkful. I'd just be like, what's it gonna hurt if I make another half-meter dig?
Yeah. Yeah, I mean, we could keep doing that, but there's also, I mean, other things that are interesting that we can go to work on, and eventually you get enough material to answer the questions that you're trying to answer. And then,
I've been on many field trip where it's a very cool spot, and people are like, oh well, I'm gonna take a sample from here, and I'm like, but you shouldn't, because you're not really gonna analyze it. You're just taking it to be cool, and it specifically says please don't take samples from here.
Yeah.
But people justify it. Well, yeah, but I'm a geologist, so like I'm just not somebody off the street. I'm like, that means you should have more responsibility because you're a geologist.
Yeah.
Like, so, yeah, but that's very responsible. I find that to be, uplifting. Gives me
like field wide, we just don't do it. We always leave stuff behind.
But does that mean like you're just waiting? Like, so say like you meet like a new colleague or something like that who has a technique that you're like, holy crap, like that's pretty cool. We should test it at like, this cave in Armenia. Like that's what you're saving it for? Or like, how do you know when to go back?
Yeah, exactly. So we did that exactly a few times. One, when I sampled, because we had at that point stopped the actual excavations. And so then everything gets like filled in with bags and stuff to protect all of the like sediment that we excavated from collapsing. And so then when I was sampling for this work on fire and climate, we just kind of took all that stuff out and then cleaned off all the profiles and sampled it, and then we did it again this past year for some work that's in progress, because there are new techniques that allow you to extract DNA directly from soil. So there's a group in Germany, yes, who have now extracted like ancient modern human and Neanderthal DNA just from the soil, just because they were around the area.
What?
How Germans are good, I tell you.
Yeah, they're
you know
amazing.
how that works?
Is it just like dead skin cells or something? Or?
I don't know how it works. I could make something up, but
no, go ahead, make something up. I'll believe it.
You could tell me.
What you're telling me is it's ghosts.
Yeah,
they're extracting ghost DNA.
Yeah, it's ectoplasm in the soil.
That's incredible.
Yeah, so we went back and so they published some of this in a cave called Denisova. They've done some of this work, and then we collected samples.
So
Denisova, which is German for ghost cave.
Ghost DNA cave.
Now, wasn't there like a... Oh, go ahead, Jesse.
Yeah, I was going to say, Chris and I, so when our one site, your site, I don't want to say our site, in Georgia, like
it's our site.
It's our site. Thank you.
Georgia, the state.
The state, not the country.
I want this to be on the record here. It's our site. But one of the things after we were done doing field work is like, we kind of filled it in, yes, to prevent collapse, but also to prevent poachers from coming in to get like bones and stuff. How do you protect this?
Oh, that's a good question.
We can't directly protect it from anything like that, other than Lucicurt, the cave that I had been talking about, is right next to a village. So the people there like know what's going on. They know that there's archaeologists who come. We work with some of the people from the village, so a lot of times they just keep an eye on things over the course of the year. There's quite a bit of pride in their cultural heritage in Armenia, so they care about protecting that kind of stuff.
Mm-hmm. Well, it didn't stop the Egyptians from looting the pyramids.
That is true. Yeah,
so it gets to a point where
Yeah.
Hey, so you mentioned? Did you say the cave was like 2 minutes ago? It was called Denisova with a D.
Yes.
Is that where they have the Denisovan hominids?
Yes. So that's that same cave where they identified them from the pinky bone. They then went back and did the soil DNA analysis.
What?
Wait, whoa. Hold on. They were able to identify this hominid species just by looking at a single pinky bone?
Yeah, so this is why for archaeologists, the Denisovans are such a confusing thing to work with, because they were just kind of going through, okay.
Oh, no, I'm sorry, just go ahead. For sure.
Okay, so they were going through like, you can tell the pinky that it's going to be some sort of hominin. And so they've been going through and analyzing the DNA of all these different things. And then this one pinky bone came back different, and it wasn't modern human, and it wasn't Neanderthal, and it's something else. So that's why there's not really a species designation. They're just called Denisovans, and there's no sort of anatomical knowledge of what it looked like, because it's just from a pinky bone, and we just know it's different.
So that's the only evidence of the Denisovans, is just a pinky?
That was the first evidence. So at this point, I think there are a few more.
Yeah, there's a molar.
Yeah.
And like a partial jawbone from last year.
Yeah. So they're very, very limited.
Yeah.
And those aren't really diagnostic.
No.
So it's Dr. Evil.
From this, I'm throwing in like I'm an expert. This is from my past 45 seconds of Googling.
Yeah, I'm reading the Wikipedia page real fast.
Yeah, but the Denisova cave is like, it's like a mysterious looking cave. It's a pretty sweet looking cave. Just from my knowledge of caves, it's a good one.
Yeah,
I'm looking at a picture of the cave right now. We'll have to look and link this on the.
That's a good looking cave. I've been.
It's all right. It's all right. I mean,
I've been.
You see one cave, you see them all. I don't know.
I've been in some ugly caves before.
I've been in a fair number of caves and/or mines, and this is a good one.
It's a good one. It's good. Jesse approved.
Jesse approved.
So
he's going to start a travel blog.
Cave travel blog.
Yeah. Would you go on this cave? Yes. All of them just say yes.
It's just like a yes or no blog. It's like yes, it was.
So I've heard of this term, like of the Denisovans. Obviously, I'm a geologist. I just heard of the name. Is there like a thing about these Denisovans that makes them so important, or?
Yeah, they're not. They can't identify them.
Yeah,
so you just said that.
Well, I know that. Like, okay. See what I have to deal with, Alex? They're weak.
Yeah,
dealing
just
with
like
this.
they're like a dead link of like.
But they also, some modern humans have Denisovan DNA in them.
What?
Yeah, so they
Okay,
also
so-
intergressed and bred somehow.
So you had some creepo Denisovans with trench coats and hats walking around. The Homo sapiens are like, oh, it's a good looking person.
Homo sapiens are the creeps.
Who is the creep? That's what I want to know. Is
Yeah,
it
yeah.
Denisovans?
That's a good point.
Neanderthals?
Or the
Homo sapiens?
Denisovans, just like those creepy ones in the back, like, Rufy and the Neanderthals and the Homo sapiens.
And creep versus pervert. What term?
This took a turn. I'm sorry.
I mean, they didn't have the internet back then, so they didn't even know about getting to learn the stuff firsthand,
Yeah.
Here's
They had the internet. It was just dial-up.
the humans that have Denisovan. Do they also have Neanderthal?
In some cases, I think. I want to.
I would question.
I might be wrong about
my
this, but I want to
ancestors.
say that the group of people who has the most Denisovan DNA are in New Guinea, Papua New Guinea.
I'm
Okay.
looking at their.
That's where the cave is, right?
No, the cave's in like
Russia.
Russia.
Syria.
Oh, okay.
Yeah.
But I'm looking at they're showing like the migration line, and it goes down to New Guinea and stops.
Yeah.
But yeah, I'd really question my ancestors if it had like both Neanderthals and Denisovans, these species that are living at the same time.
Yeah, just a mix of all of it.
Yeah.
So here's what we're going to do, Alex. We're going to have you back on the podcast. And in the meantime, me, Jesse, and Steve are all going to take 23andMe tests, right? And here's what we're going to do. We're going to see what percentage Neanderthal each of us are.
Okay.
And you, as the expert, will just by looking at us, right?
You'll have to guess.
I'll guess
your
who,
prediction.
match up.
Who has the most amount of Neanderthal in them? Okay.
Oh, man. Do you want to take a guess now?
I mean, Jesse's got some really hairy knuckles, so he might be a little more Neanderthal. I don't know.
I've already said I'm built for the cold. I don't know.
Jesse is a psychopath. He will wear flip-flops in the wintertime. There'll be snow out, and he's got to let the dogs breathe.
Only go camping in the summertime and the winter.
He's actually the only person. You're the only one in this group that has gotten frostbite, right?
Yeah.
Yes, I've not gotten frostbite.
I never got frostbite.
I went camping this weekend in the backyard with the kids, and
okay.
It was like 52 degrees overnight. It was, some would say, like perfect.
Perfect camping weather, yeah.
Mm-hmm. Too hot. I woke up like twice. I'm like, it's so hot. Why is it hot in this tent?
You also had 2 kids in the tent with you.
Yeah, and they had taken. I have like 6 sleeping bags, so they took 4 each or 2 each. And,
just took all of them.
Yeah, took all of them. So I had my like Sub-Zero one. So that may have contributed.
That may have contributed. Yeah.
Maybe. We used to do this thing every year. Actually, I only went on it once. I was dumb enough to do it just, once. Maybe smart enough to only do it just once. But it was, because we had a name for it, the Donner Party or?
Yeah, the Donner Party.
It was a winter camping
Death March. Yeah.
Yeah. Winter camping trip. And it was the most miserable night I've ever spent. I think we did one night. We were out in like Gettysburg, Pennsylvania. It dipped down to like 12 degrees at night, and
that's not even the worst.
How cold was it?
No, that wasn't the logging trail one. I didn't do that one.
The logging trail one we abandoned after one night. Yeah, we were in like a foot of snow, and it was 0 degrees.
Yeah,
we had 1 bottle of moonshine. We couldn't anyway.
Yeah. Well, yeah, we're getting way off topic, but so Alex, yes, we'll have you back on with our DNA results.
I feel qualified to comment on that. So
yeah,
yeah. You're more qualified than anybody else we've ever talked to.
Here's
So.
we'll make a contest out of it. Alex will give us tasks to do. Like, if you were really a Neanderthal, you would be able to do like, this task and that task. We'll all carve out like arrowheads out of obsidian and see who makes the best arrowhead.
Give us like wood to chop or something. Yeah.
Well, they didn't have arrowhead.
It's way harder than you would think. I've tried because like when I teach archaeology classes, we have to give like flint knapping demonstrations. It's so hard. I'm terrible at it.
So do you know what they use to carve the obsidian?
Oh yeah. So usually you just take a harder rock.
Just another.
Yeah.
Well, that's what happens, man. These guys, they don't have
rocks have different hardnesses.
I mean, I don't know. I'm not a geologist.
Yeah.
I'm gonna beat another rock with one rock and another rock.
But that's what happens. Like, you don't have Facebook, you don't have HBO, there's no Game of Thrones. Like, what are you going to do? Oh, let me make this rock really sharp. Like, stare at the stars, and that's about it, man. If you're a Neanderthal, you mate with Homo sapiens, and that's about it,
Yeah, there's a lot of interesting archaeological research about the learning process of flint knapping. Like, can you go to an archaeological site and identify something that was made by somebody who was bad at it, or somebody who was a child who was learning?
Oh, wow.
I don't know if the answer to that is yes, but I mean, it's something that surely is represented in the archaeological record. But to differentiate that between some sort of like finished product is difficult.
That sounds like another contest. Give us all, we'll all submit our tools to you, and you can figure out who made what.
Yeah, we're gonna like we're gonna just like bleed everywhere.
Yeah. I would not recommend starting with obsidian. Take some flint or something.
Talc. We'll do it on a talc first.
Yeah. Yeah.
I like this. This will be like the Idiot Olympics. This will be great. Oh man.
Well, seriously, thank you so much for coming on. This has been an excellent episode.
Yeah, thanks for having me. It's been fun.
Yeah. And your junior geologist certificate will be in the mail coming soon.
Okay, good.
Yeah, we'll give it to you. We'll give it to you. We're like an honorary geologist from the Flannelcast.
No, you have one credit to complete, and that's watching all of Indiana Jones.
Watch a movie about an archaeologist to become a geologist.
Because that makes sense. That makes a lot of sense.
Thank you.
Yeah.
Thank you.
No, we should make them watch what are the good geology movies? The first,
Dante's Peak.
Dante's Peak.
We got
Dante's Peak probably older than him.
No, Dante's Peak came out in like the mid '90s, man. Like Pierce Brosnan when he was like James Bond.
Yeah, 97.
97.
Okay.
And
I was
Alex,
born
how
in
old?
90, so.
All right. So he was 7.
Yeah.
That's a great time to watch Dante's Peak. I don't know.
I showed it to my kids this weekend.
No, what we should do is we should make Alex listen to the intro Flannelcast theme song and identify the movies where the clips came from.
Oh, there you go.
I don't think I'd be able to do that.
No,
I don't watch movies
I don't
at
think
all.
I'd be able to do that.
Yeah, I don't know if
Yeah.
Maybe we should make that a contest for the fans. It's I don't know. There's only three. Only three clips.
Listener questions. Shout it out there. If anybody's still listening an hour in. So no, but seriously, thank you very much.
Thanks. Yeah.
We really appreciate you coming on. And we
so
look forward to following your research in the future.
Thanks.
If Alex, you want to send us over some links, now we'll get back to the link thing that Steve said like 45 minutes ago.
Yeah, I can send some links.
We'll post this on the website, geologyflannelcast.com. If anyone's interested in kind of looking up some more information about Alex's research, we'll have those links posted. We'll have the stuff from Jesse's Corner that he was rambling. I don't even remember. What did he talk about? I don't know. It doesn't matter. It doesn't matter. It's fine. Tectonics or something like that. I don't know.
Yeah.
Whatever. But yeah, we'll have all that stuff posted. And
don't forget to check us out on Patreon, on Instagram, the Facebook.
Yeah.
Our website.
You can email us directly. Go to our website, email us. We'll respond.
Yeah, eventually.
Someone will do something.
Yeah.
That is the most fitting silence I think that we've ever had. Perfect. We're podcasting people. All right. Yeah. So that's I think that's a wrap for today. Thanks everyone for listening. We love you guys. Take care, and we see you guys next week with another action-packed episode of the Geology Flannelcast. Thanks a lot, guys, and we love you guys. Bye.
Bye.